PC that is connected to your subnet. The objective of this lab is to ensure that your PC, please do not change its IP address, we have predefined it for you. You will find the objective of this lab is to have that PC pinging the radius to server, which is an NT system up here in the front of the room. That will tomorrow become your home office connection when you do VPN tunneling. You will all be called remote office connections. 1, 2, 3, 4, 5, 6, 7, and 8. Any questions about the way the lab is connected up, the equipment? Yes, there's, well, not in my equipment section, not in my section, but farther down in the VPN section where Tim is, there is some connection, some diagrams here of the lab. If you have a question about your IP addresses, on top of each Edge Guardian box, you should find remote office connection with your number on it. Okay? It tells you your internal LAN, your primary LAN module, the IP address we want you to assign it. That is the IP address that you assign to the front of the unit when you power it up. Okay? When you are there and it asks you for a gateway, follow the instructions for no gateway. Because it is flat, it's on the network, it's on the 245. Okay? The mask is all natural C, 255.255.255.0. Your VPN LAN 2, your secondary LAN module, or the hardware module that does the IP tunneling, please assign it this IP address. You will do that later in the lab. It will show up. Okay? Your laptops. We assumed everybody would bring at least one laptop. As I said, connected into the 203 module in the back of the N9K chassis and assign it to 245.100 of your subnet. Okay, 245.110, 245.210, etc., around the room. Your PC, the tower PC that is already on your desk, is already assigned that it should be these addresses here. The exception might be 7174. The lab says it's 7173, but the PC is actually 7174. We had a bit of difficulty last week, we left it that way. Okay? You see that? The NT server in the front of the room. As you can see here, we have given it the 200.4 IP address. It is already on the VPN LAN 2 side of an Edge Guardian. That Edge Guardian is at 245.1, and its subnet is 200. Okay? And this NT is at 200.4. Your PC on the table, the tower, needs to be able to ping 200.4 by the end of this lab. Ultimately, it would be very nice if you could ping all of the other PCs on the extension of the tables here. That is the objective of this lab. Without that, tomorrow will not be successful for you. Exactly.
Class C mask.
Class C, 255.255.0.
Okay, gateway to...
If you're going to use a gateway for your laptop, let me suggest you use 245.1. That's the system up in the front of the room. You should recognize where you are. Enable the IP forwarding. Set RIP version, RIP enable. Go to the interface. Select the ILAN 1 interface that you have given an IP address to. Enable it, set it to RIP version 2 type 40, if that's the network configuration you're looking for. If you follow the predefined configuration path, you shouldn't go wrong. And the point here is, go down through those first 8 pages. When you're done with the routing, you do not have to finish it at that time. Exit the path, test your routing, do your pinging. If you're happy, go back into the path, skip down those 8 pages, and continue from there to do the VPN configuration. That's the path I would take. Okay? Until you get to be a power panel user, I strongly recommend you follow and look at the predefined configuration paths. Joe, there's over 300 pages this thing can serve you. Where do you go to start?
Oh, no, the term is just...
After a year and a half, I still use the configuration paths. Is everybody set? Any other questions? Okay, it's 9:27. They have not had a morning break.
Yep.
Okay. I suggest 15 minutes maximum,
Okay.
quarter of 10.
Quarter of 10?
Okay? Take a break, quarter of 10, 10:45.
Lifetime.
Hey, Steve.
Very nice.
Could one of us use our...
We ready to start?
Oh.
Do some tunnels? Huh? All right, the chapter that we're on here, you can see in the front end is the Edge Guarding Training chapter. You all have that.
But it doesn't say new product.
That's because he's got the latest rev. You're an old down rev. Okay. Easier to change the slide than the copies.
Okay.
Him. You're late. Him.
Why? Didn't you say 10:45?
Nice try.
Steve, could you douse the lights for me back there?
We haven't been doing-
No, you're going to put him asleep. Leave lights on.
Leave lights on? Everybody can see okay? Sure. What we're going to do now is, the past day or so, you all have become, from what I understand, gurus on configuring the guarding for IP routing. That's gone pretty well for you. Now what we're going to do is dive into the VPN piece of this product, differentiating what makes it the Edge Guardian, if you will, opposed to the Edge Blaster and other Edge products that come out. So basically what we're going to do today is we're going to talk about how we do configurations for VPNs. We're going to go through the user interface and explain to you how to manipulate that to set up tunnels. We're going to talk a little bit about very general discussion on how IPsec and IPESP works in this product. I'm not going to go into a lot of detail. When I get done with that discussion, you folks are going to have a lot of questions, and Simon's going to peel in here later on in the day. He's going to start going into HMAC hashing and MD5 and all that kind of fun stuff. So by the time you get through all of that, I think you'll have a pretty good understanding of how this technology works. We're going to actually we're going to do some labs today. We're going to set up some tunnels to the front of the room to a home office area here. We're going to play with the EdgeSoft clients. For those of you who wish to install it on your laptop, we'll actually tunnel you through to the home office or start off by tunneling you into your individual Edge Guardians here on your desktops, and then later on we can peel in Radius and authenticate you here up front. So we got a lot to cover. Probably going to move pretty quickly. I hope to keep this speak 45 minutes, under an hour, I hope. Bear with me, I'll go as quickly as I can on this. So we're going to get right to the labs. These documents, the Xyplex network documents, yes. And actually they're already live on the web. You know, if you go to the support advantage section of the Xyplex web, we've already pushed these documents up there like that. I'm talking about the top piece here.
Right, now the other documents.
Now these other documents are just reference books that I bought a couple of reference books when I was, as you folks are, trying to learn this technology. Put them up there because, well, I found Internet Cryptography book was very helpful, and it was a real good read. And the applied cryptography book is, well, that's real sleeping material, but it does get into the nuts and bolts pretty well.
I'm sure you can find any references here.
That's true too. That's true too. So more or less talk about this, like I say, 2 sections. We'll do a speak, and then we'll start working into the labs. And we'll get this all configured up. We'll work the tunneling in a couple of different modes. You folks will be happy. It's worked pretty well. Give you a good understanding of how to set this up. Okay, let's dive right into it. What happens here, essentially, with IPsec or IPESP is that we establish point-to-point IP tunnel with other Xyplex VPN products or other Edge Guardians, and in the future N3K with a VPN cam. Of course, now also with EdgeSoft clients. We establish point-to-point tunnels that way. We can also create almost like what we call a full mesh, where you can establish a point-to-point tunnel to a home office, and of course all of the remote offices could also establish point-to-point tunnels with one another, so that they all could intercommunicate through tunneling protocol. And we do all of this configuration on this product today through the HTML interface. Steve, I think, started showing you the path. There's a guided path that we're going to take for configuring virtual private networks, and we'll be working through that today. Part of this presentation is I'm going to take you through the screens because there are some gotchas that I want to get in front of the audience here before we go off into the lab. Of course, I won't spend too. I know Simon touched on this in his presentation. Obviously, the IPsec portion was peeled off of IPEF IPv6 and adapted into IPv4. The mechanism we use in that is IPESP encapsulated security payload. Extract the original IP packet into a tunnel datagram. Okay, and then we hash that, encrypt the heck out of it, and pass it through the internet. Pretty interesting, as complicated as this will seem to you as we get through the day, there's really, I found, two main points that you just really need to understand, and that is basically that with this protocol, the first thing that we do is using something called ISACAM Oakley, an Oakley protocol, is we establish keys. We establish a tunnel, we authenticate the tunnel between one end device and another. Once we do that, then the next step is that we start forwarding data, IPsec data, encapsulated data through that tunnel. The first step is that you authenticate with one another, you key with one another, each device does that. Then once the keys are accepted by each side, and they both agree to let one another's data pass through, then we pass data in the IPESP tunnel. Now, some of the underlying mechanisms that we use is we use something called the digital signature standard. We use this ISACAM protocol, ISACAM Oakley protocol, now called Internet Key Exchange. Kind of really cool stuff about this is that once you get on top of your game here, wait a week, right? Because there's a new draft. It's awesome. You guys will love it. It's not so bad, but essentially what happens here is that in this protocol, I guess to put it simply, is that more or less each side has a signature or a fingerprint that's very unique. As these units power up, they create something called a private key. This very large random number that they use, random number generator. This private key is created on the box when it powers up. There is no way to access or identify what that private key is. It's held inside of the box. You can't see it or get at it. And then later on, what happens is we use this protocol where from that private key, each box generates what we call a public key. This public key information, signature, if you will, is passed across the pipe to the other receiving device. The two devices actually can identify each other through their signatures. And what's really interesting is that these two sides can transfer data and authenticate themselves without knowing each's private key. Really neat underlying algorithms where using this public key technology and these large prime numbers, hashing algorithms, that they can identify and authenticate that a packet truly was sent from the originator that they expect it was sent from, and vice versa. And of course, there's some hashing algorithms that are used to do this. This is just a picture trying to show you what this would look like. At the top piece, obviously, is your typical IP datagram, if you will. Of course, after applying IP or the IPESP, we then do is we take this original datagram, we strap it inside this packet, and we build a new IP header. On the front, we add some ESP trailer information. On the back, some authentication information. Once we strap it inside here, then we do this keying mechanism and these hashes, we encrypt all this data. We heard some of the terms, 40-bit, 56-bit keys, or whatnot, that's selectable and configurable on these devices. We send this packet across the internet. What's really interesting about this is notice this IP address here essentially becomes the destination of the other VPN unit you're talking to across the internet. Again, like I said, you can establish it more or less like a point-to-point tunnel. So, the thing to remember about that is that needs, of course, be a routable IP address, right? So if we're going to pass that across the internet, you'll see that when we configure these things. You're basically going to be telling your units that you're talking to an IP address out here. And this unit knows all of your IP addresses, and I'm going to be talking directly to you with the destination IP address of each of your ROCs here. I bring that point out because we run into some interesting stuff with NATs, network address translation. Currently, the IPsec, the IETF drafts have not quite figured out how to deal with NATs at this time. So we run into some situations where customers want to put this up and they don't have routable IP addresses. And yes, I say some Cisco router running NATs or something like that. This is another example. This one's kind of unique here. Is that this is an example of an ES2 packet from a client running the tunneling software or the shim. Again, same type of principle. We put a header on the front of the packet, some trailer information. But notice the IP addresses. This situation here, this is an IP address, for instance, that was served up by the local ISP where the user established their original network connection. Destination IP address is that of a corporate edge guard. And then there's some really cool stuff inside here we'll get into later, where what we do is we have the option to then make this user what we call a virtual node on the corporate net backbone. You can see, I don't know if it's clear in your diagrams, but the source address inside, encapsulated inside here, is actually also a 121 network address. A couple of interesting notes to mention here is that in order to make this all happen, if you have an existing firewall or router with IP filters enabled and whatnot, we need to punch some little pinholes in those filters in order to let this protocol through. Basically, IPsec or IPESP uses a protocol type 50. So an example that you might be familiar with, or what makes some sense to you, is that here, for instance, on the corporate network, we're using our traditional IP filters, and we blasted a little hole in the filter that basically allowed a protocol type 50 to traverse the filter, and then we used a qualifier and basically said to a specific IP address, which was that of the VPN card on the edge guard. Okay. The other thing that we talked about is the two-step process. Fortunately, this should be reversed. Step 2, step 1 here, ISOCAMP uses a UDP 500. So we also, through the firewall or IP filters, allow UDP port 500 to traverse. And again, we qualify that to a destination of the VPN card specifically.
You got that typo there.
Okay, which one is it?
UPD?
Oh, sorry. Yep. Hey, I got it right on the second bullet.
Hey, just FYI.
No, thank you. I'll fix
Okay.
that. Sorry. Okay, here's another interesting fact right now, is that the digital signature standard that we're using right now allows Xyplex devices to communicate or fingerprint themselves or identify themselves with other Xyplex devices. Unfortunately, this algorithm does not allow us to interoperate with all other vendors that are using like an IPsec digital signature standard of their own. Yet, correct. And hang with us here. Simon's going to talk about something called digital certificates, which is in the works. It's going to make us all very happy. But currently today, we can talk to Xyplex here. Of course, we can talk to our partners who helped us develop this thing. We can talk to their gear as well too. We're all sharing the same digital signature.
Now, this is the same thing for everybody, right? Or
That's correct. In other words, anybody who's using DSS, I think is what you're asking.
yeah.
That's right. So they can kind of interoperate or communicate or
No, I mean,
authenticate.
we can't interoperate with anybody else, but so can the other guys. I mean, nobody else can interoperate with anybody else anyway.
Correct. Correct. And digital signatures that they're working on here supposedly solves all this problem by creating some trusted party authentication. And I won't go into that right now because Simon's going to take you through that. But the answer to your question is yes, that's correct.
Well,
I'm sorry. There could be. The only ones I know about, of course, is Red Creek, but that's correct. That's correct.
How about
Absolutely.
Cisco?
So Cisco was using this technology. Right. Yes. Okay. A couple of implementations here. Let me just work through them really quickly. Two ways to, that's more than two, but here's two major ways to implement this product. The first example, A, of course, shows a configuration where, for instance, we are right on the internet. A good example is the Edge Guardian that's running down here, for instance. We've got a T1, a full pipe T1 right up to BBM. Okay, and then on the other side we've got a LAN interface that straps into our 254 network. This implementation just merely shows, of course, that we could sit right on the edge there, tap directly, using a LAN connection and a LAN connection, and fit right in like so. The second implementation here might be if there is a router or some type of a device here that the customer or whatnot does not wish to upheave, then of course we can sit behind that router. And the configurations that you folks did with Steve here is very similar to that, where you've used two LAN interfaces essentially, right? A VPN LAN 1 and then an iLAN 1, if you will. You've kind of done an Ethernet to Ethernet or a local network to local network connection. Very similar to what you've done right here. Currently in our network today, there's like there's one edge blaster that's serving up the modems, and then there's two other edge guardians that are running here. We have an edge guardian today that's sitting here right on the internet, providing our internet feed. However, there's another edge guardian that's basically sitting in this implementation right behind it. In other words, we haven't quite got to the point where we've collapsed all the functionality into one box. We're close to doing this. Questions? No?
I have a.
Yep.
It's kind of specific to my little application. So if we put the original code back in.
I'm going to get to that. You're talking about inversion and hang for a minute. Note that question. I'll get that. We'll get it. We're going to talk about that. Okay. Another example here, just showing, for instance, a typical maybe point-to-point or back-to-back implementation between a corporate site and another remote site, and then also showing an edge-top client connecting in remotely to either one of the two or both of the edge guardian units in the remote office or the corporate data center. Okay. In our implementation association, there are two different modes of ESP we can function. Mode 1, if you will, or one of the modes is called ESP open. And what ESP open basically means is that when you have created tunnels to other networks, if datagrams are received on the VPN card interface that are destined for networks that are not part of the what we call a security association or the pre-configured tunnels, then in open mode what happens is the VPN card acts like a repeater, if you will, for those datagrams. Perfect example of this would be, again, our site, where we have some tunnels established with a couple of remote offices, but in the same time, or the same hand, we want to provide access to the internet for the web, for the people on the 128 network. So what happens there is that in this open mode, we have this ability for networks that are associated as part of the tunnel, the data comes into the card and actually gets sent through, encrypted, or in the dirty, if you will. It's another term I use. And packets, IP datagrams that are destined for networks that are not part of the tunnel association merely get repeated, or we call it bridged, if you will. Passed right through the card. Enclosed, it's a tighter configuration in that in a closed environment, basically something a little bit different happens is data that is destined for associated tunnels that are configured, again, like in open, gets encrypted and passed across, but any datagrams that are not part of the tunnel association get dumped. It's dropped right on the floor. Right? The question was?
It doesn't have an open mode.
That's right. That's like a passing the clear only and then ESP mode, right?
So basically, if you're connected by a PC and a dial-up,
Yes.
into the internet,
Yes.
not from an edge guardian, you'll have to get first into the edge guardian of the connection, and then you can go ESP over to the internet. You cannot have a PC set up.
Right, the PC needs to manually be toggled, right, between ESP mode.
Yeah, but it cannot be done on a packet basis. So it means either on either or. Not
That's-
both at the same time.
That's correct.
I think they're gonna add
The
that.
comment is,
They're gonna add that support for the client. Yeah,
That's
it's just
what
a
I-
matter of time.
If you had like a second interface on the PC, fake, like they do with the Microsoft, you have a VPN interface and a regular one. Both of them are active at the same time, which means, you know, where to get
But Windows 95 doesn't support the dual stack. And see, the client, the EdgeSoft actually goes into the TCP stack.
I know.
So that,
But the Microsoft is fairly ready. They had a second interface to the PC, called the VPN interface, on the MS-DOS 1.2.
Oh,
You got two APTPs.
right.
It's not the same application, but it's a similar problem. How do you find between the two? Either you encrypt or you don't. Right?
good.
So to have both of them active at the same time, you have the two interfaces sharing the same module.
Everybody understand that the discussion basically was another thing, good point, we'll show you that a little bit later, is that with the client software, you can turn it on or you can turn it off. So either you're tunneling or you're not. So for instance, like at home, when I'm tunneling to my ISP, right, if I want to serve up to Redbooks, IBM Redbooks or something, and then look at some data or whatever, then I basically go to pass on the clear mode right through my ISP and I'm on the internet. And when I come back and tunnel in here, then I toggle to ESP mode and then boom. So I have them
You cannot be
being
connected to links at the same time.
correct. Right.
Genius. So
Yes.
the ESP open, ESP closed, is that on the client software or is that on the box?
That's on the box itself.
So if you had it set to close, no matter what you toggle, you couldn't get through.
Right, if you're set to closed on the Edge Guardian, right, the only datagrams that are going to get through the box are the ones that are part of the tunnel association, right? So there are some applications apparently where, where customers are, in other words, if they're not interested in providing service to untunneled networks. They just want to dump those packets on the floor. So they can go into a closed mode environment.
They're allowed.
My opinion, yes.
Post corporate and
A couple of diagrams just to reinforce what we said, just drive this one a little bit, okay? So, what you can see here, trying to simulate, not a great diagram I guess, but is that this is an open mode configuration where these dotted lines on your books are basically showing an encrypted tunnel or established tunnel. What we're just trying to show here is a clear wire. In other words, this is a different network out here, let's say. Could be I don't know, some site on the internet or whatnot. And right, customer, and we're passing the open mode, so therefore packets that are destined for this other network out here are passed and clear. And that site is accessible. You can just see the cut in the wire again here for a closed environment where once you throw the switch to closed over here, then we're not talking to anybody that's not part of the tunnel association. You're going to see this firsthand because the first lab I worked you through, you're going to go through these, you're going to see the results in the lab of what happened. So I think it'll be pretty clear once we get through lab 1, if it's not now. Okay. The first class I had, I spent a lot of time on these next 4 slides and almost felt bad about it because I felt like I was beating a dead horse. But what I realized was, as much as everybody kind of nodded their head and thought they understood, unfortunately, once they got into the configuration, they realized that they didn't. So I apologize in advance. I'm going to beat these next couple of points a little bit. Hang with me. I've got about 4 slides. When I get done, I'll stop. We'll see if we got any questions, and then we'll move ahead because it's kind of an interesting concept. What happens here is that because of this partnership, shall I say, things are not integrated quite as tightly as you've seen with, say, for instance, the T1 card. We haven't played with the T1 card too much, but with the island card. In other words, we drop a VPN card in here, there's a driver that we co-develop, and it's not exactly seamless, and that's the point that I need to get across here. Because of this right now, in the time frames we were working with and how this pulled together, there are a few quirks. A few gotchas, if you will, if you don't really understand. So I want to try and get those across to you. And then also try to show you that what we did to compensate for some of this is I spent a lot of time on the linked help. I think Steve showed you this help text links. And I'm going to beg you that when we go through that, please test them out for me, because I think that you'll find between the help and this discussion, we should be successful and bang, we'll be out this tunnel right away. All right, let's move into it. What you've done so far is you've used the 2 LAN interfaces here, one which is called VPN LAN 2, and then one here called ILAN 1. And you've configured both of these, and you're actually routing between these 2 LAN interfaces here. The second slot, if you will, or second PCI slot, has the VPN card in it with 10-base T connector on it. Okay. Now, of course, this was a simulation done for the purpose of our lab, where we used basically these 2 interfaces. But of course, as we showed in previous diagrams earlier on, we could have essentially used a LAN and a WAN and done the tunnel. In other words, a VPN interface and then one of the WAN interfaces, and we've done tunnels that way. Okay, but we've done a LAN to LAN here. I think you'll see we can transpose that into a WAN environment if you think about it a little bit. Now, here we go. Here's the different interfaces that we've built. We didn't touch this. We've got a default LAN interface that gets built when the box powers up. But basically, this is what you folks configured and played with here the past day or so. The important thing to understand here is that there's a VPN card in this box, and when you look at this box from the outside like this, it looks like a black box and all-encompassing or whatnot, and it's very integrated. The architecture, the underlying architecture basically is that VPN card is a node on the router interface. VPN LAN, I should say LAN 1. Was it? LAN 1 or LAN 2? I might have a typo there. Yeah. This VPN card itself has an IP address of its own. This is not a router. We'll see, and we'll talk more about that. It's not a router. This is a router, of course. This has its own IP address, and its IP address is actually an IP address that is on this VPN LAN interface. This is the little decoupling here. We put some addresses behind this a little bit, hopefully articulate this a little bit more. So for instance, let's just say that we created a .5 network out here on this VPN LAN interface. And see, in the VPN configuration, haven't gotten to yet, but you will, you actually assign an IP address to this card. And you can see the address you assign will be on the same network. It'll be a different node number, device number, on this network. Did not do anything like that with ILAN 1, right? You don't do anything like that today with our products, right? You assign the IP address to the interface, and then the physical logic or whatever just kind of is melted into that, into your link, if you will, just melted kind of into the interface configuration. This is a little bit different, and here's where you can touch it a little bit. Okay? Interesting here now. From this VPN card's